Question 13. Let P of t be a function such that dp dt equals 3000 times e to the power of 2t. When t equals 0, p is equal to 4000. Find an expression for P of t. The question is asking us to find a function given its gradient function. And in order to do that, we need to integrate this expression here. That will introduce a constant of integration. And then we'll need to use the boundary condition given, which is this condition here, when t equals 0, p equals 4000, to find the value of the constant of integration. After that, we can find the expression for P of t. So firstly, let's integrate dp dt. So P of t is equal to the integral of 3000 e to the power of 2t dt. Now, integrating an exponential function, it remains the same. However, we need to divide by the derivative of the index. So 3000 e to the power of 2t when integrated is 3000 e to the power of 2t divided by 2, which gives us 1500 times e to the power of 2t plus the constant of integration c. Let's apply the boundary condition. It is given that p of 0 is equal to 4000. So substituting 0 for t into this expression here and 4000 for P of t or P of 0 here, we end up with this equation. 4000 is equal to 1500 times e to the power of 2 times 0 plus the constant of integration c. Now 2 times 0 is 0 and e to the power of 0 is 1. So the equation becomes 4000 equals 1500 plus c. Hence c is equal to 2500. Therefore, P of t is equal to 1500 times e to the power of 2t plus 2500. Here is an alternative solution that does not explicitly involve integration. Now, if the gradient function given is dp dt equals 3000 times e to the power of 2t, what must the original function or the primitive have looked like so that when we differentiate it, we end up with the gradient function looking like this? Now, since it involves the exponential function, e to the power of 2t, the original function must be in this form. In other words, P of t equals a times e to the power of 2t plus c, where a and c are real numbers. So if pt is equal to a times e to the power of 2t plus c, and we differentiate this function here with respect to t, then dp dt is equal to 2 times a times e to the power of 2t. So I've called this equation number 1 and equation number 2. So notice that we have dp dt equals 3000 times e to the power of 2t, but we also have dp dt is equal to 2 times a times e to the power of 2t. Notice that the two forms are similar. Moving on. If we equate equations 1 and 2, in other words, let these two equations be equal to each other, we can find the value of a. In other words, 3000 times e to the power of 2t is equal to 2 times a times e to the power of 2t. So if we equate the coefficients, this 3000 must be equal to 2a, which means a must equal 1500. Hence, P of t is equal to 1500 times e to the power of 2t plus c. Now we need to find the value of c. Now it's given that P of 0 is equal to 4000. So if we substitute 4000 for P of t here and 0 for t here, we can solve for c. So 4000 is equal to 1500 times e to the power of 2 times 0 plus c, and e to the power of 2 times 0 is equal to 1. So 4000 is equal to 1500 plus c, hence c is equal to 2500. So putting that all together, we have P of t is equal to 1500 times e to the power of 2t plus 2500. If you have time, you can check this answer by differentiating P of t.